Okay, in this video we're doing problem set 7, and we're going to do question number 2 here. And so we're going to check the assumptions of regression for these 4 things here on the simple linear regression that we created in the first problem. And so I'm going to recreate that here real quick. I'm going to do add-ins, PHStat, regression, simple linear regression, and this thing pops up, and the Y is the revenue to here, and the X is the number of flights. And I'm going to check all these, and I'm actually going to put in a value here where this 321,000 and 95% confidence interval. Click OK, and these are the regression statistics. These are the coefficients. And so for this problem, we're going to look at the residual plot. So we're going to look at this plot here, and we're also going to look at we're going to create another plot here to check for constant variability or equal variance. And let's do that real quick. We take the residuals table, and we want to move predicted Y over here. Insert cut cells. So I've got predicted Y right next to the residuals column, and let me select these 2 columns and insert a chart, this chart that they recommend. And so we're going to look at this chart for B, and then for C we're going to do we need to figure out what the skewness and kurtosis is of the residuals. So that's this column here. Let's just do that. Data analysis, descriptive statistics, input range of the residuals, and labels in the first row. And let's put the output, we can just put that down here, and let's do this. Okay, so here we have line these up, and so we have our kurtosis and our skewness. That's not that good. And for the last one, we're going to look at the Durbin-Watson statistic. And so for that, we go to Durbin-Watson. We're going to use this tab. And we're going to use this number. And we will compare this number with our page 532 Durbin-Watson statistic, and we are using k equals 1 for one independent variable, and our sample size is 28. So we are looking, the DL and DU is 133 and 148. and ours is 0.8, so that's low. Okay, so that's not good. All right, so let's go back and discuss each of these. So when we look at the residuals against flights, and we want to check for linearity, if we open up these regression assumptions that were included in the folder, we're actually doing this one right here where we're checking for linearity, and we're looking at the residuals. That would be this plot right here, and this is the zero line right across here. Oops. From here to here, and we see that the residuals, they're pretty. There's not really a pattern here. The scatter is pretty widespread. They're spread evenly above and below for different values of x here. So in that case, I think we can conclude that our assumption of linearity is valid. Let's see, next we're going to look at that plot that we created, residuals against the predicted y, and we should be looking at the same kind of thing here. If we look at the residuals, I'm going to shade this. We see that this is the zero line here, and as the predicted y, the predicted revenue, goes from lower to higher, we see that the actual residual values are pretty evenly spread above and below. There's an outlier there, but there's not really a pattern. So I think we can conclude based on that we have constant variability. Skewness and kurtosis. Now, this one doesn't look so good. Our skewness is above 1, and our kurtosis is well above 1. Our count is 28. If it were 30, we wouldn't have to look at it. We wouldn't care so much. It's close, so that's not good. Let's see. What is this? Skewness is it's not greater than 30. Kurtosis, well, that's so anyway. So it looks like for as far as this normality, our assumption would not be valid. But actually, if we go back and we look at the actual p-value itself, which is back on the Compute tab, we do have strong significance here, and these p-values are quite small. So I think we may be okay for that reason. Okay, what's next? Durbin-Watson. For the Durbin-Watson statistic, if we look on page 436, where Durbin-Watson is discussed, there's this D lower value and D upper value, and what these values are is if your Durbin-Watson statistic ends up being lower than the lower value, then we don't have any evidence. If it's below, we can conclude there's evidence of positive autocorrelation, and so that's bad. So that means that the samples are not independent, because these are time-based. We're looking at quarters of data, and so it looks as though with the Durbin-Watson statistic of only 0.8, which is less than the value we were looking at on page 532. It is less than 1.33, so that's not good. So we have here that we do not have the I fails. The independence here fails, and the normality is questionable. So you can expand a little bit on that. Okay, I'll end this recording, and the next one will cover question 3. Thanks for watching.